Thank you. Let's start the next session, the last session before coffee. I don't have to remind you to silence your devices. Of course, you've done that already. There'll be a brief question and answer session in the end of this presentation, and I would like us all to welcome Toshi and Ryo on stage for this, I'm sure, very interesting presentation, again, of cyber threat intelligence and how we can use different methods to enhance that area. Thank you. Thank you.
Okay, welcome back first conference. We are looking forward to giving a speech in front of our audience over the about 3 years of COVID-19. I am Toshitaka Satomi from Fujitsu System Integration Laboratories. Please note our names on this slide. My name is Toshitaka Satomi, and
I am Ryusuke Masuoka, and please note that my first name spells R-Y-U-S-U-K-E, not R-Y-U-U-S-U-K-E, okay?
This is the agenda of our session. In other words, the map of our journey. We will give a demonstration and demonstration, a presentation and demonstration. After first 2020, we continued our journey to widen CTI applications. One day, I got the chance to discuss with a certain Japanese law enforcement practitioners. They have collected a lot of criminal information and would like to correlate pieces of information. For example, this information includes IP addresses, bank accounts, and so on. While I am thinking how to resolve the case, I realized this is common to other communities. We decided solving this case would meet our research topic. First of all, I was going to use the STIX format. However, as you know, plain STIX can handle cyberspace data objects only. STIX cannot store real-world data like a bank account information. Of course, I know STIX supports custom objects, and we can extend the format to handle the real-world data. Additionally, I also know the MISP standard. MISP standard supports many real-world data to save and correlate. This data can be exported as STIX 2.1 by using custom objects. I believed MISP standard and custom objects would solve it. However, we were simply too naive.
Okay, after we had discussion, I happened to open a bank account in Japan. This is a bank account application form on smartphone. And first, I was asked to provide my name in kanji, kind of official version of my name, last name in kanji, and first name in kanji. And then I also asked to provide my name in katakana, last name, and first name. That is when I realized that the problem is not as simple as we thought. Data to open an account in the United States and Japan are very different and like two independent islands. For US accounts, MISP person object it will do for it. First name, middle name, last name, but not for Japanese name. I'm going to talk about this later, but matching first name values would not be easy either. So let me give you a little lesson on Japanese before I go into detail. This is free one. Okay, so please understand that there are a variety of character sets used in everyday Japanese writing. So first, kanji character set, which is Chinese characters we borrowed from China 100 or 1,000 years ago. So this is first one. Then we have a character set for phonetic representation of Japanese, which we call katakana. And then this is a double byte version, but we have a single byte version of katakana. They look similar for human eyes, but those codes are totally different for computers. Then we have another phonetic representation character set, which is called hiragana. And we have alphabet in double bytes and alphabet in single bytes. So the last one is basically ASCII code. So those are used regularly in Japanese writing. So my name in kanji, katakana double byte, katakana single byte, hiragana, alphabet double byte, alphabet single byte. So it is really crazy. So the problems we realized is that first of all, the names are structured very differently in the U.S. and Japan. So for U.S. bank accounts, I am required to give first name, last name, middle name. But in Japan, to open a bank account, my last name in kanji, my first name in kanji, and then my last name in katakana, and then my first name in katakana. Some banks require phonetic representation in hiragana. So they're very different. First, we encountered this problem, and then secondly, so therefore, one needs to specify which field to match with which. So in this case, we decided that my first name in katakana, this is a phonetic representation, so this is the best chance to match with this one, first name in US version. So that's one thing we have to do. But then matching first name values is not simple either. So because this is a phonetic representation, there are a couple of ways to convert Japanese into alphabet. Sometimes they are different, but I got lucky to have the same one for all conversion methods. But the thing is, they do not match with mine in US. So RYUSUKE and RYUUSUKE. This one I picked up when I was 11th grader for my first passport, and I've been using it for US bank accounts and Bitcoin accounts as well. So, and it isn't unusual to use this version for my name. So those are kind of things that we realized to deal with when even matching US accounts, my US account, and my Japanese account. So the matching is not science, but more of an art, a black art. So that's when I realized that we opened the Pandora's box. Yeah, there are lots of things coming out of this box. But fortunately, we had Toshi to close the box. Toshi?
Yes, thank you. Thank you, Ryu. Okay. From Pandora's box, we found many other gaps to fill. The first case is Russian family names. They use the different family names by gender in Russia. For example, men use the Libinsky as a family name, and women use the Libinskaya. Some languages add accent marks to barriers. In our country, some companies have more than 40 variations of its name. It's crazy. From the aspect of cyber threat intelligence, we use many aliases to specify a threat actor, malware, and so on. There will be many such cases in other languages and cultures. Therefore, we need easy to create custom objects and flexible matching mechanisms to deal with real-world data. Okay. This is a map of our last journey in 2020. We demonstrated SCHIP, our original threat intelligence platform, to breach human and system CTI seamlessly. To close Pandora's box, we have implemented STIX customizer and 2 matching mechanisms in SCHIP. To overcome these gaps, we add 3 features in SCHIP. The first one is STIX customizer. As I mentioned before, STIX supports custom objects. However, it's up to each chip application. And the user cannot handle the custom objects that the chip cannot support. MISP allows end user to model custom objects by editing the configuration file. SCHIP can model the custom objects by using GUI. It is very useful and easy to understand modeling method. The second one is explicit correlation. There are many fields in real-world data. We know it doesn't make sense to match between a credit card number and a telephone number. It is very important to narrow down the matching range using explicit correlation because the correlation matching consumes a lot of time. Please remember our cover page, Satomi. Satomi is my family name. However, in Japan, Satomi is often used as a first name for women. It doesn't make sense to compare my family name Satomi with the last name of women, Satomi. The last one is fuzzy matching. This function can absorb notation fluctuations. We started to absorb the gaps between English and Japanese as we used to do. Now the demo time. I will demonstrate to create the new custom object model. Next, I will configure the fuzzy matching rule to absorb the notation fluctuations. I will also set the explicit correlation rules. Finally, I will show you how matching between a Japanese value and an English value happens. An end user can set STIX custom objects and properties from this page. I have already configured a part of the XMISP object person on the right side. Of course, it is a custom object. This model is standardized by MISP. You can confirm the relation with the nodes and edges. I will try to add a pair of a custom STIX object and some properties. First of all, create the STIX custom object. Okay, fill in the name, and leave the type to object. The ellipse shape has appeared. This shape shows it is an object. Let's create a custom property node. Set the type property and fill in the name. Okay, the box shape has appeared. It means a property create an edge between custom object and custom property. And drag from object node to property node. The line has appeared with a contents label. This label is added automatically. Now I can add the property to the object. Let's create other properties. The second one is, kanji family name. As you mentioned before, kanji means Chinese character. The third property is katakana given name. Katakana phonetic representation of Japanese. The last one is katakana family name. Connect with edges, labeled contents as well. Okay, I can create custom object and properties very easily. Next, I will try to set explicit correlation between the property which I just created and the existing properties. Oh, sorry, the existing properties. The way is very easy. Just drag node to node. Fill in the rule name, in this case, first name, and click the OK button. I will set another rule as well. This case is a family name. Okay, I can set 2 rules. Next, set the fuzzy matching rules of the property. Click the specified property node and click the edit node. The setting dialog window has appeared. Scroll down, and we can show the fuzzy matching rule section. Check this to match values regardless of case. Katakana, hiragana are Japanese character sets. The left side is katakana and the right side is hiragana. Both of them mean Tokyo, which is the Japanese capital city. Zenkaku, hankaku for katakana are also Japanese character sets. Human beings can judge 2 values are the same, this one and this one. However, computers usually determine these values are different. By enabling this rule, fuzzy matching treats these values as the same. Japanese-English fuzzy matching, I will explain later in detail. List matching is for matchings that above rules cannot cover. To enable the list matching, fill the words that are considered to be the same value for each line. For example, cafe, and cafe with an accent mark is treated as the same. Or in the case of CTI, malware is often referred to by several names, so I added emotet, trickbot, and ICE ID in another text area. These 3 values are treated as the same. Okay, we can also use this function to match between slang and typo values. Tokyo is sometimes written as Tokyo. By defining, Okay, hey. By defining TOKYO and TOKIO in the same text area, 2 values are matched. Now I enable several rules and click Save button. The configuration demo is over. Let me explain about 2 STIX bundles with custom object. The first bundle is XMISP object person. This file was exported from MISP as STIX 2.1. This bundle contains Ryusuke, Ryusuke, as his first name.
Yeah, this is my first name for US banks, all right.
This value consists of alphabets. The second bundle is, XJP natural person. Of course, these objects are original. By using the STIX, we can create original STIX instances very easily. In this bundle, you can find 4 properties filled in Japanese characters. This highlighted word is used actual Japanese first name by using katakana.
Yes, I confirm this is my name in katakana, which to be matched with the one in US for the US object.
Okay. Most matching systems don't treat them as the same. This page shows graph view analytics. This function is also one of the STIX functions. In this page, we can show the 6 nodes and some edges. The center circle node means an object. Click the node, and we can show the property list from the bottom detailed window. We can also Japanese values that I just explained the previous slide. Okay, this box shows a property. This node includes Ryusuke in katakana. Okay, STIX automatically searches the correlated STIX from the database and shows the result table on the left side. One STIX is matched. This E means exact matching and F means fuzzy matching. In this case, this is one correlation is matched by fuzzy matching. Click the checkbox in the cell. Another graph has appeared, and the 2 graphs are linked with a green line. This circle node shows the XMISP object person. This value is dictionary value. This box node shows the property whose value is Ryusuke in English. This box node shows the property in XJP natural person. This value is katakana. Okay. The label of this green line is fuzzy matching. Let's click the green line. Okay, we can show detailed fuzzy matching information. The first value is Ryusuke in katakana, and the second value is Ryusuke, Ryusuke in English. In the rule text area tells us these values are matched by case insensitive and Japanese English fuzzy matching. In this way, STIX can overcome the Japanese notation fluctuations. We would like to apply the implementation to the cases in other languages and cultures. These 6 customizers, explicit correlation, and fuzzy matching can be applied not only to the cyber domain, but also to the real-world data. The demo is over. Wrap up. Here is a summary. We have implemented the new feature to match the real-world data in STIX. The first one is STIX Customizer to easily create STIX custom objects. Next, explicit correlation and fuzzy matching to make meaningful matching possible for real-world data. I believe these 3 features are vital for real data matching. Future work includes, first, we will apply these technologies to programs from the law enforcement practitioners and others. Second, faster fuzzy matching is needed because list matching consumes a lot of time. Third, study and deal with other notation fluctuation cases. And the last one is enable sharing STIX custom object schemas and matching rules. Takeaway message is easy to create custom object and flexible matching mechanism to utilize real-world data, like independent islands along with cyberspace data. If you are interested in the application of SCHIP, please join with us. We need more contributors. Please contact the GitHub account. This is GitHub account. Of course, it is neither English nor Japanese. This is the end of the talk today, but our journey continues. We will continue our journey to utilize the CTI more. Good luck with your next journey. Thank you.
And thank you from Ryusuke, R-Y-U-S-U-K-E as well.
Thank you for your
Thank you.
attention.
Thank you very much for an interesting demonstration and talk, Toshi and Ryo. And I think this can be utilized in many ways and between many languages when it's further developed. I hope you get good developers for that, good contributions. Any questions or comments? We have microphones up here and here. Please feel free to, yeah. Go ahead, the left first.
Hi, so thanks for the talk. This is indeed an issue I hadn't thought about it. And I was just wondering if you had talked with people at MISP to increase and improve the support of other languages in their taxonomies and ontologies and so on.
I'll check the MISP updates day by day.
And I think we will, but so we have done it in STIX and STIX, but I think this will be also possible in MISP as well. So we will discuss this with MISP people and make sure the world is more connected. Thank you.
Thanks.
Thank you.
So for everyone that maintains internal data sets, are there things we can do? Sorry, it's like about 6 inches lower than I needed. Are there things we can do for our internal data sets to set them up to be able to support the different rules we find as we expand out globally? So that, I'm sure none of us can build like something that covers everything from the start, but are there things we can do to set ourselves up for success later as we find the need to support different regions of the world and different structures of data?
Oh, okay, sorry. Was it just a comment or?
But so, like, if I or someone else here is maintaining a big data set, and we want to structure our data such that as we run into these challenges, like the trouble of matching, US names to Japanese names, are there things we can do initially that will make those challenges easier to overcome as we get to them? Mm-hmm. And so it sounded like something that you were able to find was the ability to support matching was a big enabler of your ability to then bridge this challenge. So if matching were maybe one of the things that was helpful to support, are there other things that we should think about supporting so that we can solve these types of challenges as we get to them?
Yes, so we have kind of future work on study and deal with other notation fluctuations. And also we are thinking of structural differences as well, and make it more, as much as possible, generic. And also we plan to kind of enable sharing object schemas and matching rules as well. So that should help it. Okay.
Okay.
Oh, sorry.
Anyone else? Any comments or questions? Okay. You can find, I'm sure, both these distinguished speakers, Toshi and Ryu, in the coffee break, which is coming up next. So thank you very much for attending this morning. Thank you.
Thank you.
Thank you. See you in Montreal and Fukuoka in Japan.